Hello everyone, welcome to my channel. So in this video we are going to learn topic second shifting theorem for Laplace transform and inverse Laplace transform. Let's start with the statement. Statement for the second shifting theorem is if Laplace of f of t is f of s, then g of t is defined, one function is defined, g of t is defined as f of t minus a for t greater than equal to a and equal to 0 when t less than a. So this g of t is here defined, and if you want to find the Laplace of this g of t, so Laplace of g of t is here e raised to minus as into f of s. So we can easily calculate f of s. So we can calculate f of s using Laplace of f of t. Using Laplace of f of t, you will get f of s, and using this f of t minus a, you will get the value of f of t, right? So just our task is to find the value of a as well as value of f of s. You can easily get the value of a using this g of t, and using this f of t minus a, you can easily get the value of f of t, and taking the Laplace transform of f of t, you will get f of s. So our task is to just substitute value of e raised to minus as into f of s. So let's begin with the example. Find Laplace transform of g of t. So g of t is here defined cos t minus 2 pi by 3, where t greater than equal to 2 pi by 3 and equal to 0 when t less than 2 pi by 3. So here we want to find out the Laplace of g of t. So students, first of all identify the value of a. What is value of a here? 2 pi by 3. So here a is 2 pi by 3. And what is this? Cos of t minus 2 pi by 3. So this is the value of f of t minus 2 pi by 3. So what is here f of t minus 2 pi by 3? That is cos t minus 2 pi by 3. So using this f of t minus 2 pi by 3, can we write f of t? Yes. So how to write f of t using f of t minus 2 pi by 3? Just remove this a. So you will get f of t. So removing this 2 pi by 3, you will get the value of f of t as cos t. Just remove a. You will get f of t. So what we are getting here? F of t is cos t. So Laplace of this f of t. So Laplace of f of t, that means Laplace of cos t. So what we are getting here? S upon s square plus 1. So Laplace of f of t is nothing but what? F of s. So question is find the Laplace of g of t. So Laplace of g of t is nothing but e raised to minus as into f of s, right? Just substitute the value of a and just substitute the value of f of s. So e raised to minus 2 pi s upon 3 into f of s, that is s upon s square plus 1. So this is the final answer. Here we got the Laplace of this function g of t, that is e raised to minus 2 pi s upon 3 into s upon s square plus 1. Let's see one more example for this. Second example, let's start. So let's see the second example here, students. Find the Laplace transform of g of t, that is 5 sin 3 into t minus pi by 4, t greater than equal to pi by 4, and equal to 0 when t less than pi by 4. So again we will solve this example using second shifting theorem. So this pi by 4, this is nothing but what? Value of a, and this 5 sine 3t minus pi by 4, this is nothing but what? F of t minus pi by 4, right student? So using this f of t minus pi by 4, we can easily write f of t. So we are using second shifting theorem. So Laplace of j of t is nothing but what? E raised to minus as into f of s. Okay, we know the value of a, just we require to find out the value of f of s. So here f of t minus pi by 4 is here 5 sine 3 t minus pi by 4. So here f of t minus pi by 4 is given. Just write f of t. So using f of t minus pi by 4, can we write f of t? Just remove this pi by 4. So if you remove this pi by 4, what we are getting? 5 sine 3t. So this is our f of t. Just take its Laplace transform. So Laplace of this function, that is Laplace of 5 sine 3t. So here 5 is constant, so take outside. Then Laplace of sine 3t. We know the standard formula of Laplace of sine at. So Laplace of sine at is nothing but a upon s square plus a square. So here value of a is 3. 5 is already there, so keep this 5 as it is. Laplace of sine 3t is nothing but 3 upon s square plus 9. So this value is nothing but what? 15 upon s square plus 9. So this is our f of s. Just substitute value of f of s and just substitute value of a. So our final answer is Laplace of j of t is e raised to minus 2 pi s upon 3. I have substituted the value of a into f of s. Value of f of s 15 upon s square plus 9. So this is our final answer. So here we have seen the two examples of second shifting theorem for the Laplace transform. Let's see the second shifting theorem for the inverse Laplace transform. So now we are starting the second shifting theorem for the inverse Laplace transform. Let's see what is the statement for the second shifting theorem. Statement is L inverse of f of s. L inverse of f of s is f of t. Then if you want to find the L inverse of e raised to minus as into f of s is nothing but what? F of t minus a, where t greater than equal to a and equal to 0 when t less than a. So if you want to find the L inverse of f of s, so we can use the second shifting theorem. Let's see the example, it will be more clear. So find the inverse Laplace transform of e raised to minus pi s into 1 upon s plus a. Students, we can easily compare this because this bracketed term is nothing but what? F of s. That means here we want to find the L inverse of f of s. So just compare this. So you can easily compare here this 1 upon s plus a. This 1 upon s plus a is nothing but f of s. So what is f of s here? 1 upon s plus a. Value of a, that is pi, value of a is here pi. So using these two things, what we are getting? Value of a and value of f of s. Just compare this. So L inverse of e raised to minus as into f of s. L inverse of e raised to minus pi s into 1 upon s plus a. Means here we are second shifting theorem is applicable. Value of f of s is 1 upon s plus a and value of a is here pi. So L inverse of this, we required f of t minus a just. We required the value of a and just we required the value of f of t minus a. But how to calculate this f of t minus a? Yes, we can easily calculate f of t minus a using f of s. Taking inverse transform of f of s, you will get f of t. And using f of t, we can easily write f of t minus a. So students, first of all we will find out f of t. So L inverse of f of s is L inverse of 1 upon s plus a is nothing but e raised to minus at. So this is a standard formula. L inverse of 1 upon s plus a. This is a standard formula, that is nothing but e raised to minus at. So this become f of t. So here we got the value of f of t. So using this f of t is here e raised to minus at. So using f of t, can we write f of t minus a? Right. Yes, we can write t minus a. What is value of a here? Value of a is pi. So using f of t, here we are writing f of t minus pi. Just replace t by what? T minus pi. So e raised to minus a outside it, right? Replace t by what? T minus pi. So here we got the value of f of t minus pi. So last step, we are interested in finding the value of L inverse of e raised to minus pi s into 1 upon s plus a. So using second shifting theorem, what is this value? F of t minus a equal to 0, t less than a. Just substitute value of f of t minus a. So here f of t minus a, value of a is pi. So that's why f of t minus pi is here e raised to minus a t minus pi, where t greater than equal to pi and equal to 0 when t less than pi. So this is our final answer. Means using second shifting theorem, we can easily calculate L inverse of e raised to minus pi s into 1 upon s plus a. This is very simple theorem. Let's see one more example. Let's see the second example. Find inverse Laplace transform of e raised to minus 3s into 1 upon s square minus 9. Students, in the exam you can easily identify this type because this expression is similar to this L inverse of e raised to minus as into f of s. Yes, value of a, here value of a is here 3. F of s, value of f of s is 1 upon s square minus 9, right? So here we want to find the L inverse of this function. So we required f of t minus a and we required value of a. So using f of t, we can easily write f of t minus a. So first of all, using f of s, using this f of s, we will find out f of t because L inverse of f of s is f of t. So here we are taking inverse of f of s. So again here is a standard formula we are using, L inverse of 1 upon s square minus 9. So standard formula is, standard formula for this inverse, L inverse of 1 upon s square minus a square is 1 upon a into hyperbolic sine at. 1 upon a into hyperbolic sine at. So here value of a is 3. So that's why I have written here 1 by 3 hyperbolic sine 3t. So this is value of f of t. So using this f of t, we can easily write f of t minus a. So last step is what? Laplace of e raised to minus 3s into 1 upon s square minus 9. That is equal to f of t minus a, where t greater than equal to a and equal to 0 when t less than a. So for the given example, we can easily write f of t minus a. Yes, f of t is what here? Hyperbolic sine 3t. Just replace t by what? T minus a. So what we are getting here? 1 by 3 as it is. 1 by 3 as it is, hyperbolic sine 3 into value of a, here value of a is here 3. So just replace t by what? T minus 3 and equal to 0. So t greater than equal to 3, function is 1 upon 3 hyperbolic sine 3 into t minus 3 and equal to 0 when t less than 3. Just 2 steps example, using f of s calculate f of t and using f of t write the f of t minus a. That's it. So this is all about the second shifting theorem for inverse Laplace transform. I hope you understood this concept of second shifting theorem for Laplace as well as inverse Laplace transform.